Welcome to this lecture on projectile motion. This is second part of the lecture, and in first part of lecture we saw that projectile motion in xy plane, so this is xy plane, occurs along a parabola which is inverted. We have the range of projectile, horizontal distance. We have y maximum or height of the projectile, and the total time taken by projectile in air is time of flight t. Then we started with an initial velocity v0. This is v0. Resolved it into two components. A component along x-axis, दूसरा along y-axis. This is v0 sine theta, and this component along x-axis is v0 cos theta. And with these two components, we try to understand that how this motion is a combination of two one-dimensional motions in a plane. We also came across the relations like value of x-axis, that if this is the position of body projectile, then the horizontal distance which it covers in time t is x, given by v0 cos theta multiplied by t. We also found that if y is the coordinate here, so this is the y coordinate of this point P, then y is equal to v0 sine theta into t minus 1 by 2 gt square. The horizontal motion is a uniform motion, whereas vertical motion is a uniformly accelerated motion. We came across the relation for time of flight, which is twice v0 sine theta by g. Then we have y maximum or height, which is equal to v0 square sine square theta divided by 2g. We have range, the horizontal distance covered during time of flight, which is twice v0 square sine theta cos theta divided by g. Now before I go further, I would like to give you another perspective कि इस motion को अगर हम observe करते हैं as two one-dimensional motions, how we can help the process of visualizing this motion. I have a three-dimensional coordinate system in my hand. You can see one system fitted on the board. The motion of projectile is taking place like this. So this is x-axis, this is y-axis, and this is the z-axis. The motion is taking place in xy plane. Now let's change the view. अगर हम view को बदलें, इस view को हम ऐसे देखते हैं. I look at it कि ये है y plane, ये है x और ये है z. This is the z. तो अगर हम इस view को बदल देते हैं, how I would find things happening कि अगर मैं यहाँ से देखूँ, that means we are trying to look at the plane. ये जो है ये y axis है, हम y axis को सिर्फ देख रहे हैं, and we are seeing from this side. फिर एक और हम यहाँ से भी देख सकते हैं. I can see it from the top. That means जब मैं top से देखता हूँ, I visualize कि what is happening along the x-axis, the x-axis, when I look at from this side. But let's see, when I look from this side, what I see from here. तो imagine कि एक viewer जो एक projectile यहाँ से throw किया गया है इस direction में, और एक projectile एक parabola बना रहा है, वो इसको यहाँ top से देखता है. What he sees कि एक point जो है, वो point कुछ इस तरह से move करता है. तो आप imagine करें कि the person is trying to visualize कि x-axis पर क्या हो रहा है. तो x-axis पर एक point ऐसे चलता जा रहा है, और इसकी जो चलने की speed है इस direction में ऐसे, वो स्पीड यहाँ पर आके रुक जाती है. ये स्पीड है, कांस्टेंट स्पीड है. इन अदर वर्ड्स, जो कंपोनेंट v0 cos थीटा है, दिस v0 cos थीटा, ये मोशन का एक कांस्टेंट है. ये वक्त के साथ साथ बदलता नहीं है. इसकी बात हमने लास्ट लेक्चर में भी की. और ये v0 cos थीटा हर वक्त एक जैसा ही रहेगा. दिस वाज कि एक आदमी या एक ऑब्जर्वर जब इस पर्सपेक्टिव को देखता है कि एक्स एक्सिस पर क्या हो रहा है और यहाँ से देख रहा है, उसे एक ऑब्जेक्ट ऐसे दिखाई देता है चलते हुए with a constant velocity. He is ignoring the motion of that point up or down. उसको आप भूल जाते हैं थोड़ी देर के लिए. So he watches this. That means यहाँ से लेके यहाँ तक जो distance देखता है point को चलते हुए, that becomes range. That becomes range. Then let's change the perspective again. फिर से हम इसकी नज़र को ऐसे करेंगे. तो मैं पहले x axis पर देख रहा था top से. Now I look from this side. कि y axis पर क्या हो रहा है? What's happening on y axis? On y axis what you observe is कि a point is going upwards. पहले point बड़ा तेज जा रहा था. Then it slowly slows down. फिर ये point एक खास point पर या एक height पर जाके रुक जाता है. And then it returns back. So you observe something like this. कि something going up initially आप यहाँ से देख रहे हैं. Something going up initially faster speed slows down slowly, comes to rest and then returns back. So you will visualize कि जो पहला motion आपने देखा, which is the motion along x-axis, that motion was a uniform motion. With a constant speed something was moving. और जो दूसरा आपने देखा, पहले ऑब्जेक्ट तेज चलता है, फिर स्लो डाउन हो जाता है, और स्लोली एक खास पॉइंट पर आके रेस्ट पर आ जाता है, फिर नीचे रिटर्न करता है, अप डाउन मोशन. So this is how we break this motion into two kinds of perspectives, two one-dimensional motion. अब देखिए टाइम ऑफ फ्लाइट का मतलब यह है कि अगर हम इस पर्सपेक्टिव से देखें फ्रॉम द जेड एक्सिस, तो आपको ये ट्रेजेक्ट्री दिखाई देगी, और इस ट्रेजेक्ट्री से आपको टाइम ऑफ फ्लाइट का अंदाजा बन सकता है. अगर मैं ये कहता हूं कि जो इसकी वर्टिकल वेलोसिटी है, दैट वर्टिकल वेलोसिटी इज v0 sin थीटा इनिशियली, और यहाँ पर जो इसकी वर्टिकल वेलोसिटी है एट हाईएस्ट पॉइंट, जिसको हम vy कह सकते हैं, दैट बिकम्स इक्वल टू 0. तो मैं एक बड़ी सिंपल कैलकुलेशन कर सकता हूँ. द कैलकुलेशन वुड लुक लाइक दिस. एक्सेलरेशन is change of velocity divided by time. If I say t is time, then t becomes change in the velocity divided by acceleration. मैं acceleration के केस में g की बात कर रहा हूँ. That's acceleration due to gravity. Now, what is the change in the velocity? Here, the velocity final is 0. Here, the velocity was v0 sin theta. और acceleration, चूंकि ये एक retarded motion है, मैं minus g ले लेता हूँ. So I take this as minus g. I have 0 minus u v0 sin theta divided by minus g. This comes out to be v0 sin theta divided by g. I have done nothing. मुझे ये अंदाजा लगा कि how much time will be taken by this object taking the vertical part of motion to reach this point. और अगर आप देखते हैं कि time of flight जो है, it is twice of this time, twice of t. I have the answer. It agrees with this one. Now, if I say that range R, capital R, is the horizontal distance covered by this projectile during the time of flight, very simple. So I can calculate range. Range के लिए I use the formula that it is velocity multiplied by time. Which velocity? Velocity along the horizontal direction, that is v0 cos theta multiplied by time. Which time? This time. So that is twice v0 sin theta divided by g. So your answer comes to be twice v0 square sin theta cos theta divided by g. Here is the range. Now, if I think of y maximum, again very simple. Y maximum is that thinking of the vertical motion again, I have f certain point where final velocity is 0. I have the certain point where initial velocity was v0 sin theta. So I would like to get y. So I use the relation v square minus u square is equal to 2as. Final is 0 minus u square is v0 sin theta whole square is equal to 2 into minus g into h. H is height, and you get the expression that h comes out to be this is v0 square sin square theta divided by 2g. Minus sign will get cancelled on both the sides. So I have the expressions for me as this. Now my point here is कि जब भी आप फिजिकल सिचुएशन को विजुअलाइज करते हैं, हमारे पास कई तरीके हैं इस सिचुएशंस को मैनिपुलेट करने के, और फिजिक्स की ब्यूटी ये है कि विदाउट डिपेंडिंग टू मच ऑन द मैथमेटिकल एस्पेक्ट ऑफ इक्वेशंस, हम फिजिकली अगर एक प्रोसेस को विजुअलाइज कर सकें इन डिफरेंट मैनर्स, आवर आंसर्स विल कम एंड दे विल बी एग्जैक्टली ट्रू एज फार एज देयर मैथमेटिक्स इज कंसर्न. तो वो तीन इक्वेशंस बिल्कुल वही है which we have derived otherwise through some different methods. So remember here कि a two-dimensional motion is nothing. It is visualizing two identical or different. Identical भी हो सकती है और different भी हो सकती है. two identical or different one-dimensional motions happening simultaneously at the same time. One very important aspect of projectile motion, we go further. Now, what is my next point about this projectile motion is कि जो ये v0 sin theta यहाँ पर एक velocity थी, यहाँ पर आके zero बनी. Did it happen abruptly? No. This process takes a certain time and happens over a period of time. We are interested now in finding out the situation at point P. I take an arbitrary point P, obviously between the highest point of trajectory and the coordinate initial point of the trajectory. मैंने कोई point P ले लिया और I would like to find out that what is velocity at point P. सबसे पहली चीज कि जो point P पर velocity है वो जरूरी नहीं है कि उसका direction वही हो जो v0 का था. No, not necessary. So I take this as velocity. Some velocity at time t, I call it as vt. और आप डायग्राम में देखोगे कि जो vt है उसका ओरिएंटेशन और v0 का ओरिएंटेशन अब अलग-अलग है. Let me call this angle as angle alpha, not theta. अब ये theta नहीं, this angle alpha. I have this velocity again resolved into two components. One component I call this velocity as vt. T stands कि ये किस टाइम पर velocity हम ले रहे हैं. So I have vt equal to जो ये component होगा x component, it will be vt cos alpha as usual. जो ये component होगा it will be vt sin alpha as usual. So I can write something like this, that velocity vt which we are talking at point P is equal to जो इसका x component है that is vt cos alpha I cap gives that it's a component along x-axis plus vt sin theta, that is this vt sin theta into j cap. J cap indicates that it is a velocity along y-axis. अब जो एक simple algebra vectors का हमें ये कहता है कि if you take magnitude of this vector vt, इसका जो magnitude होगा that will be simply the x component जो इसका x component है whole square plus y component whole square. So what is x component? Its x component is this. What is y component? It is this. तो मैं इस x component को थोड़ी देर के लिए vx कह देता हूँ और जो इसका y component है उसको मैं vy कह देता हूँ. तो it is simply under root of vx square plus vy square. Now something very important about vx and vi is कि जो vx है ये time के साथ साथ बदलता नहीं. जो initially था it continues to remain, जो vx है it continues to remain equal to the initial value that is v0 cos theta. बड़ा important इसको याद रखें. In other words, I can also say कि this implies कि अगर मैं vx को कहता हूँ that it is vt cos alpha. Vt cos alpha is the meaning of vx. It will always be equal to v0 cos theta. ये relation important है, इसको मार्क करके रखें because in solving number of problems related to projectile motion ये एक बड़ा useful formula होगा और बड़ा useful relation होगा. What about vy now? Vy is not equal to this value. It is vy which has changed. Vx has remained same throughout the motion. जो vy है it has slightly decreased. और अगर आप पिछले lecture का velocity देखें कि what is velocity along the vertical direction, you will realize it is v0 sin theta minus gt. So you can go back to the previous lecture where we derived कि इस equation को differentiate करके हमें vy मिलता है and vy would be equal to v0 sin theta minus gt. Our answer has come about vt, which is velocity of the projectile at any point. उसका जो magnitude होगा, that magnitude will be given by, that magnitude is given by the formula. I have the formula with me now. This will be like this. So it is under root of vx square, that is vx whole square plus vy whole square. I substitute for vx, which is v0 cos theta whole square. I substitute for vy, which is v0 sin theta minus gt whole square. I get the result. यहाँ से आपको मिलेगा v0 square cos square theta plus v0 sin, इसको ब्रैकेट को ओपन करें तो this is v0 square sin square theta, that is a square plus b square, that is gt होल स्क्वायर, तो a माइनस बी होल स्क्वायर है -2 इंटू v0 साइन थीटा इंटू gt। दिस कैन फर्दर बी सिंप्लीफाइड। अगर मैं इन दो में से साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा कॉमन ले लेता हूँ, सो व्हाट आई गेट v0 स्क्वायर इंटू कॉस स्क्वायर थीटा प्लस साइन स्क्वायर थीटा, ये दोनों v0 स्क्वायर कॉमन आ गए, प्लस gt स्क्वायर माइनस ट्वाइस v0 साइन थीटा gt। दिस गिव्स यू फर्दर, आप इसको 1 बना सकते हो। सो दिस इज द रिजल्ट that this comes out to be, we have v0 square, so this is equal to root of v0 square into 1 plus gt square minus twice v0 sin theta gt. So the dependence of this velocity at time t is clear on t. G a constant है, theta is the initial angle of throwing or angle of projection, v0 is the magnitude of initial velocity, g here is constant, this is constant, so the dependence of this vt on time is very obvious, it will be changing with respect to time. And how does this change now occur? If we give the value to the direction of vt, इसके direction के लिए भी हमारे पास एक तरीका बड़ा simple. The direction of vt can be seen from this point. Again, यहाँ देखें, तो यहाँ पर अगर हम लेते हैं इस angle tan is alpha का tan alpha, so what I get something like this. So I have for the direction of vt tan alpha, so tan alpha you will realize is equal to from this triangle, इससे, तो this is perpendicular divided by base, जो ये perpendicular है, this perpendicular is what we wrote as vy, so this is vy, और जो ये है this is vx, so what I get the ratio tan theta becomes equal to vy by vx, that vy by vx we can determine like this, so it is vy divided by vx, ये देखिए vx और vy की वैल्यू, so this is vy, this is vx, यहाँ से लेके यहाँ तक, so we have the ratio tan alpha equal to, so we have v0 sin theta minus gt divided by v0 cos theta. अगर आप इसको रेशियो को डिवाइड करते हैं, न्यूमरेटर will give you v0 by v0 will be cancelled, sin theta by cos theta is tan theta minus gt divided by v0 cos theta. फिर से डिपेंडेंस बड़ी सिंपल और क्लियर है, that the value of alpha is going to change because tan theta is going to be a constant of this whole motion, and theta is the initial angle of projection. So time की जो dependence है वो फिर से clear है, that the value of alpha will depend on time, and this can further be written like this, that we have alpha equal to tan inverse of tan theta minus g by v0 cos theta into t. So this dependence on time is again very clear, that alpha is going to change with respect to time, तो इसको भी आप ख्याल में रखिए. Now we can play with these two equations, इस equation के साथ और इस equation के साथ, इन दो के साथ हम थोड़ा और भी कुछ results निकाल सकते हैं. And one such result would be significant कि what will happen to value of Vt if I substitute this point. ये बड़ा एक conspicuous और बहुत ही important point है इस motion का. इस point पर क्या होता है कि जो v by 0 बन गया, the only velocity which is left out becomes v0 cos theta. That means it returns to the initial value, जो ये value है, because throughout this path this v0 cos theta is not going to change. ये हमेशा यही रहेगा, it will be v0 cos theta throughout the path, it's not going to change. वो मैंने इससे पहले भी आपको कहा कि horizontal motion एक uniform motion है, so it's going to remain always v0 cos theta. This arrow and this arrow are of same length and same direction throughout the motion. So let's point out कि what would happen if I substitute vy equal to 0, which indicates कि जो alpha की value इस point पर है, that becomes equal to 0. So let's work out कि what will happen if I have alpha equal to 0. So we work out that what will be the situation if alpha is equal to 0. आप तब तक एक expected answer भी बना सकते हो कि the expected answer would be, you will get something close to this point जो इसके साथ associated property. So let me substitute tan alpha equal to 0, I have tan alpha equal to tan theta minus gt divided by v0 cos theta. I am substituting tan alpha equal to 0, so 0 is equal to tan theta minus gt divided by v0 cos theta. I have tan theta equal to gt divided by, so this will go to the left hand side, gt divided by v0 cos theta. This can further be written as sin theta divided by cos theta is equal to gt divided by v0 cos theta. Cos theta gets cancelled out on both sides, so I get t is equal to v0 sin theta divided by g. A very peculiar result, बड़ा आसान. हमें फिर से वो टाइम मिला जिस टाइम में ये ऑब्जेक्ट इस पॉइंट को अचीव करेगा जिस पॉइंट के लिए अल्फा की वैल्यू 0 डिग्री है. और अगेन यू कैन रियलाइज कि ये जो है दिस इज हाफ ऑफ टाइम ऑफ फ्लाइट, and if I have to make time of flight, that will be 2t, which will be again 2 into v0 sin theta divided by g. Isn't it very simple? Again, the result जो हमने पहले agree किया है कि time of flight will be twice v0 sin theta divided by g. So we have obtained from this relation the same result. Next is, what would you expect कि अगर मैं ऐसा करता हूँ कि I put small t equal to capital T. When I put small t equal to capital T, what happens? Let's see. So we want to find out what will be the impact अगर हम small t को capital T के बराबर लें. Capital T का मतलब कि जो time lapse होता है between the point of origin and the point of landing, that is capital T, time of flight. तो using the equation, हमारे पास equation है tan alpha is equal to v0 sin theta, क्या we can put it, हमने already यहाँ पर इसको tan theta डिवाइड करके tan theta बना है, माइनस g, अब small t की जगह मैं कैपिटल T लिख रहा हूँ, डिवाइडेड बाय v0 cos theta gives us tan theta minus g into कैपिटल T आपको ऑलरेडी पता है, it is twice v0 sin theta divided by v0 cos theta. So v0 and v0 gets cancelled and we have twice v0 by, sorry, this is, so it is v0 sin theta by g. So g and g also gets cancelled, so that gives you tan theta minus, this is twice sin theta by cos theta is tan theta, minus twice tan theta, that is minus tan theta. इसको हम ऐसे भी लिख सकते हैं कि tan alpha is equal to minus tan theta, tan एक odd function है, so it is minus theta, which leads कि alpha should be equal to minus theta. How does this now settle? इसका मतलब है कि the moment a projectile started with some initial angle, जो उसका angle of projection था initially, that angle was theta. After completing the trajectory, जब ये यहाँ पर hit करता है, it hits at an angle that is alpha, or alpha is angle subtended by its velocity with respect to horizontal. So at this point, the angle subtended by its velocity, this is the velocity with respect to horizontal. ये मैंने anti-clockwise direction में लिया है, इसको मैं clockwise direction में लेता हूँ. It is that way कि these two angles are of opposite sign. Theta का जो opposite होगा, that will be minus theta. Theta I take in anti-clockwise direction, minus theta I take in clockwise direction. A very important result has come out, which says कि जब projectile एक पूरी trajectory complete करने के बाद hit करता है at the point of landing, the velocity is subtending an angle minus theta with the horizontal direction. So whatever was the angle of projection will also be the angle at the time of landing. That's very important. And we can also prove later कि अगर magnitude wise जो यहाँ पर velocity v0 थी, the same velocity will be there at the time of landing also. Next I go to the highest point, which is again a very significant part of this whole scheme of things. जो highest point है इसकी trajectory का, उसकी कुछ characteristic properties हैं, जो properties आपको याद रखनी होगी. One such property is कि at the highest point of trajectory, this is the highest point of trajectory, like this. At this highest point, your vertical component have velocity Vy is equal to 0. Or the only velocity projectile have here is equal to the initial horizontal component y V0 cos theta. If I ask that what is the kinetic energy at highest point, so kinetic energy at highest point would be equal to 1 by 2 m mass of the projectile multiplied by velocity at the highest point, which is V0 cos theta whole square. So that way it is 1 by 2 m V0 square cos square theta. So please remember कि at the highest point, even though जो vertical velocity है वो vertical velocity 0 तो है, लेकिन net velocity 0 नहीं है, तो net kinetic energy भी 0 नहीं है, because net velocity is not equal to 0. What about the potential energy at this point? अगर ये height h है, very simple. In gravitational field, अगर एक object near to surface of earth हम move करते हैं, then its potential energy is equal to mgh. So this will be equal to mgh. And what is the value of this mgh? You understand, it will be m into g into maximum height. आपको पता है that it is equal to v0 square sin square theta divided by 2g. So g and g gets cancelled. This gives you 1 by 2 m into v0 square sin square theta. अगर हम total energy की बात करें, that what is total energy at this point? The total energy would be given by the sum of kinetic energy and potential energy. So total energy is equal to kinetic energy plus potential energy, that is 1 by 2 m v0 square cos square theta plus 1 by 2 m v0 square sin square theta. If you take 1 by 2 m v0 square common, you have cos square theta plus sin square theta, that makes it 1 by 2 m v0 square. So v0 is कि जिस initial velocity से थ्रोअर ने एक projectile को project किया था, उसी velocity का square हम लेते हैं, and that gives us the total energy. You will agree with me कि अगर initially आप देखें, at the initial point the kinetic energy was there, but potential energy was 0. So at this point again the kinetic energy is there, potential energy has come up, लेकिन the sum total of the two does not change. क्योंकि यहाँ पर अगर पोटेंशियल एनर्जी 0 थी तो काइनेटिक एनर्जी थी 1 by 2 mv0 स्क्वायर, और यहाँ पर दे हैव नाउ बाइफरकेटेड, और उस बाइफरकेशन में सम टोटल जो दोनों का है दैट हैज रिमेन्ड सेम. दिस इज व्हाट वी कॉल लेटर लॉ ऑफ कंजर्वेशन ऑफ मैकेनिकल एनर्जी इन केस ऑफ प्रोजेक्टाइल मोशन. I can also talk about linear momentum at the highest point. जो highest point है वहाँ पर linear momentum होगा mass multiplied by velocity at that point. तो you will agree with me in this case ये बन जाएगा m into v0 cos theta into I cap, because the velocity is parallel to x-axis. We can also think about the angular momentum, but we leave that part to the rotational dynamics. जब हम rotational motion में बात करते हैं, we can think about the value of this angular momentum. और the last thing I would say here कि जो ये point है, इस point पर velocity जो body की है, ये इसकी velocity है, और acceleration जो है they are perpendicular to each other. जो acceleration due to gravity g है, it's downwards, this velocity is purely horizontal. So at this point the velocity is perpendicular to acceleration. ऐसी काफ़ी कम situations आपको physical world में मिलेंगी where velocity is perpendicular to the acceleration. This is one such situation where velocity is perpendicular to the acceleration. So I hope that we have made out most of the points related to projectile motion. We have learned that projectile motion is a two-dimensional motion comprising of a uniform motion along x-axis and a uniformly accelerated motion along y-axis. We have derived equations of the range, time of flight and maximum height. We have used the perspective कि किस तरह से अगर हम purely x-axis को देखें और purely y-axis को देखें, किस तरह से इस motion के कुछ खास characteristics हमारे सामने आते हैं. उन perspectives को use करके भी हम range और time of flight और maximum height की equations develop कर सकते हैं. We have seen conservation of energy during this motion. We have seen that the highest point is a peculiar point where the body has vertically zero velocity and velocity is perpendicular to acceleration. These were some of the highlights of this. Thank you.